Section 3.3, Video 2, Compound Interest. In this video, we will cover the following objectives: solve problems involving compound interest, compute compound interest formulas for principal, rate, and time, solve problems using annual percentage yield. Compound continuously. Compound continuously is the maximum amount of interest that can be calculated for an account. The formula for continuous compounding uses an irrational number, E, which is approximated as 2.71828. The compound continuous formula is amount equals principal times that number, irrational number E, to the exponent of R times T, or the product of R and T together. Example 5. Hayes deposits $6,500 into a savings account that earns 2.8% annual interest, compounded continuously. Find the amount in the account at the end of 3 years. Also, find the amount of interest earned. Part A. To find the amount in the account at the end of 3 years, we're going to use our compound continuous formula and fill in the information that we know. So the principal is the amount deposited, $6,750. The rate is 2.8%. Written as a decimal, that would be 0.028. Compound continuously means we're using the compound continuously formula. And the last information we need is T for time. In years, that would be 3 years. And let's fill in that information. P for principal, 6,750. E is that irrational number. And in the exponent, we need R times T. I'm going to go ahead and calculate that here first. R times T is going to be 0.028 times time of 3 years. So our exponent of R times T is going to end up being 0.084. And I'm going to fill that in, 0.084 as the exponent. Let's go ahead and calculate 6,750, and we're going to use our calculator to find e to the power of 0.084. And as a decimal, I get 1.087628894. Multiplying by 6,750, we get an amount in the account as $7,341, and when rounded, 50 cents. Part B says to find the amount of interest earned. Remember, Part B, the amount of interest earned is the amount in the account minus the initial deposit of the principal. So the amount in the account is $7,341.50, and the principal was the amount initially deposited, $6,750. We get $591.50 as the interest. Let's take a look at example 6. Alana deposits $5,350 into a savings account and would like for her deposit to accumulate to $7,000 in 6 years' time. If interest is compounded continuously, find the annual interest rate of the bank account. Round to the nearest hundredth of a percent. So let's find out what information was provided. The deposit of $5,350 would be our principal. The amount that it needs to accumulate to is $7,000. We know that our time is 6 years. And what we don't know is our rate, and that's what we need to find. So let's use our compounded interest formula, and our amount is $7,000, our principal $5,350, and now for our exponent, we're going to have our rate times 6 years, which we would typically see that written as 6R. Since we can't calculate e to the 6r exponent to the 6r power, let's go ahead and divide away that multiplier of 5,350. to both sides of the equation. And on the left-hand side, we get, and I'm going to keep all those decimal places, 1.308411215 equals e to the 6r power. To get to that exponent, I'm going to take the natural log of both sides of the equation. So natural log of that decimal 1.308411215 equals natural log of e to the 6r exponent. And that exponent becomes the front multiplier, 6r times natural log of e. And remember that natural log of e is equal to 1. So that really means we have our natural log of 1.308411215 equals 6r. And to solve for r, we can divide by 6 to both sides of the equation. And we find that our rate is approximately equal to 0.04480222647, or when converting that to a percentage, it would be 4.480222647%, and rounding to the nearest hundredth of a percent, we would get, the hundredth is the second decimal, 4.48% as the approximate interest rate used. Let's take a look at example 7. To compare accounts, an annual percentage yield is often used. The annual percentage yield is equivalent to 1 year of simple interest rate, but it includes the information from compounding, whether you compound quarterly, annually, semi-annually, or monthly. Marin is opening a bank account, and she is offered 2 different interest rates. Account A offers an annual interest rate of 4.15%. So account A has a rate of 4.15%, compounded semi-annually. So semi-annually tells us our M is going to be 2, while account B offers an interest rate of 4.1%, and it's compounded monthly. So compounded monthly is going to give us an M of 12. Okay, I'm going to go ahead and convert each of those rates to a decimal. So 4.15% would be 0.0415, and the decimal for 4.1% would be 0.041. Let's use our annual percentage rate yield so that we can have a comparison between these 2 different accounts. So our annual percentage yield is 1 plus that rate, which in this case on account A is 0.0415, divided by M, semi-annually is a 2, to the exponent of MM is also a 2, and then minus 1. So let's calculate our annual percentage yield. So we have 1 plus, and whenever we calculate and get our decimal, we get 0.02075 to the second power minus 1. I'm going to keep going with account A, adding the 1. We get 1.02075 to the second power minus 1. Calculating the exponent, we get approximately 1.041930563 minus 1. And so our annual percentage yield after subtracting 1 would be 0.041930563. Or changing it to a percentage, we're going to get 4.193056%. Or rounding to the nearest hundredth, we're going to get 4.19%. Looking at account B, making our calculation, our annual percentage yield is 1 plus 0.041 divided by monthly is 12 to the exponent of 12 minus 1. So our annual percentage yield is going to be 1 plus, calculating our 0.041 divided by 12 is 0.0031, and my calculator gives 66667 to the 12th power minus 1. Adding the 1, we get 1.003166667 to the 12th power minus 1. Going to the 12th power, we find a decimal of 1.041779301 minus 1. And then subtracting the 1, we find out that we have 0.041779301. Or converting it to a percent, we get 4.1779301%, or about 4.18%. So we see when we compare what their annual percentage yield or the equivalent simple interest rate would be, that count A ends up being a better choice because it ends up being a higher annual percentage yield for the savings account. And that ends example 7.